Assalamualaikum and a very good day. I bid to the International Invention and Innovative Competition juries. My name is Nabilla Afzan Aziz. I am the project leader for Hydrabloc to reduce water for oil well. My advisor is Associate Professor IR Dr. Muhammad Zaidi Jaafar from Universiti Teknologi Malaysia, followed by my team members Arisa Roslan, Dr. Iskandar Dzulkarnain, Yuvein and Dr. Berihun Mamo Negash from Universiti Teknologi PETRONAS. Hydrabloc is an innovation that we would like to introduce to address high water production issue that is commonly reported during oil production in most oil producing countries. One of the field scenarios in Malaysia is cross-flow between rocks. This happens when water tends to flow in high-purity rock at large amount and it bypasses the oil zone. The amount is very high when it produces through the oil well. So when water produced along with oil, it usually leads to several issues such as corrosion issues in tubing, pipeline, formation of scales, inadequate storage in order to store this produced water, and environmental spills in order to discharge produced water. Gel treatment is an approach that our team would like to use as it is able to navigate in confined spaces and it has the capability to plug the pore space of the rocks. The problem statement for this project focuses on the usage of polymer and crosslinker in order to generate a viscous gel. It's reported that precipitation occurs when we use a polymer and crosslinker, and the amount that is being used are high, which incurs significant costs. The injection mechanism that is being used are alternating slugs, which is among factors that are being reported to cause failure for it to perform in order to plug the pore probes. And it is also reported that there are gel plugging that occurred quite early during the injection as soon as the combination of polymer and crosslinker is inside the rock. There are three objectives that were devised in order to develop this innovation. The first one is the synthesis cross-linked polymer with coating system for high-purity water-bearing rocks. The second objective is to evaluate swelling performance of different concentrations of polymer at reservoir setting. And the third objective is to integrate the plugging performance of the cross-linked polymer in the porous media. The porous media here is the sandstone core sample, and the reservoir setting is at reservoir pressure and temperature that reflects the offshore peninsula Malaysia. The first stage is formulation, where we go through chemicals that could form polymer to withstand subsurface reservoir pressure and temperature. Second stage, synthesis, is where we develop the micro-sized particles and we develop a coating layer that coats the polymer in order to enhance its behavior. Third one is a static test, where we check on the swelling capacity, how much expansion in volume the moment the polymer is being activated. And the last one is the plugging performance, which is a dynamic evaluation with a continuous series of injection in order to check how much purity is being reduced in the rock. We would like to share findings based on our rigorous chemical screening in order to develop our innovation. The first one is monomers. The monomer choice is able to develop the resistance of the polymer at our intended setting. Crosslinker is able to create a stable polymer backbone. Additive is able to increase the swelling capacity up to 20% from the combination of monomer and crosslinker only. And coating system is able to slow down the gel swelling process by 10% in every minute. Hydrabloc is the outcome from our successful synthesis of cross-linked polymer and coating system. With the innovative coating system, we are able to enhance the polymer behavior, and we tested it at 90 degrees Celsius and 2000 psi setting, and the performance have showed 90% permeability reduction. The novelty of this invention is the coating system that is able to improve the polymer behavior, which can be used in the oil and gas industry. The contribution of this polymer as partition of technology, where it successfully plugged high permeability layers, and contribution towards well operated to reduce issues of corrosion in pipes and reduce the need to store this produced water. We have disseminated our findings in SPE Production and Operation Journal, and we have submitted to present in Offshore Technology Conference Asia 2024. Thank you to our main funder, YUTP Fundamental Research Grant, and institutions of Universiti Teknologi PETRONAS and Universiti Teknologi Malaysia. Thank you for listening to our innovation from the Hydrabloc team.